Hey everyone, hope you're doing well today. In this video, let's go ahead and use some given information to find out the exact values of 5 remaining trig functions when we're given 1. So again, these are the 6 trig functions that we're looking for, and we're given that sine of theta is equal to 8/17. That's the ratio, so we can start with that one. And if we know that that's going to be 8/17, we might as well just go ahead and write what cosecant is, and that's going to be the ratio of 17 to 8, or its reciprocal. Next, let's try to remember where things are positive. Here's my where stuff is positive chart. Now, since we know that sine of theta is equal to 8/17, and that's a positive ratio, we have to think about where sine is actually positive. Well, sine is positive in quadrant 1, right, because everything is positive in quadrant 1, and sine is also positive in quadrant 2. The two quadrants where sine and cosecant would be negative are going to be over in quadrant 3 and quadrant 4. Now, to narrow it down even a little bit more to figure out if theta is in quadrant 1 or quadrant 2, we need to look at this bit of information over here, where we know that tangent of theta is less than 0. So if tangent of theta is less than 0, that means it's a negative ratio. Where would tangent be negative? Well, tangent's positive in quadrant 1, so it can't be over here. So we know that we must be looking in quadrant 2. Now that we know that theta, or our angle measure, is in quadrant 2, let's go ahead and try and draw a triangle there. So try to remember that sine is going to be opposite over hypotenuse, also known as y over r. So when we go ahead and draw our triangle here, when we do our theta, we want our opposite side to be 8. So I'm going to go ahead and draw a line coming up here, and I'm going to call that 8. And we also know that our hypotenuse is going to be 17. So whatever this line over here is going to be, this is going to be 17. All right, so if theta is going to be this angle measure right over here, then we can go ahead and draw our triangle. And we don't know our adjacent side or x value, we just know our y value or opposite side and our 17 or the hypotenuse. To figure out the adjacent side or x length along the horizontal, we can go ahead and use Pythagorean's theorem and remember that we can say that x squared plus y squared is equal to r squared. And we are looking for x, we'll leave that alone, plus this 8 squared is equal to the 17 squared. And then 8 squared is going to be 64, and I believe 17 squared is 289. If we take away 64 from both sides, we find out that x squared should equal 225. And if we take the square root of both sides, x should equal 15 here. So we know that x is equal to 15, or that's the length of it. Just keep in mind that this is going to be negative 15 because we moved to the left into quadrant 2. So we've got to make sure we use a negative x value. Okay. Now we go ahead and use that information for cosine. Cosine of theta is going to be what? Adjacent over hypotenuse. So here's the adjacent side of negative 15 over the hypotenuse of 17. So it's going to be negative 15 over positive 17, or also known as x over r. So we'll go ahead and write negative 15 over 17. And then for secant, that's going to be the reciprocal of negative 17 over 15. Finally, for tangent of theta, that's going to be the opposite over adjacent, or 8 over this negative 15. And so that's also y over x. So for tangent, we can go ahead and write 8 over negative 15, or negative 8/15. And for cotangent, we'll flip that upside down and say it's negative 15 over 8. Let's try another one together. For number 2, we're given that cotangent of theta is equal to negative 4, and secant of theta is less than 0. So we're looking for 6 different trig functions, but we are already given one to begin with. So we know cotangent of theta is equal to negative 4, so we can go ahead and write that in for cotangent. And that's the same thing as negative 4 over 1, right? So if we go ahead and write that as negative 4 over 1, then we know that tangent is going to be the reciprocal, and that's going to be negative 1 over 4. So even though we're looking for 6 different trig functions and we're given 1, we're actually given 2 if you just know to flip one upside down. Now let's go ahead and use that first bit of information and look at where stuff is positive. So looking at our chart here of where stuff is positive, cotangent would be positive in quadrant 1 because everything is, and it would also be positive in quadrant 3. So it says that cotangent is going to be negative 4, so it's negative, so it can't be in these quadrants, right? So we can go ahead and say that we know that theta is not going to be in this quadrant, and we know that theta is not going to be in this quadrant. It's got to be in quadrant 2 or 4. So we've narrowed it down from 4 quadrants down to 2, and we need to narrow it down to just 1 so we can pinpoint exactly where we're looking. And we know secant of theta is less than 0, which means that secant is going to be negative. Well, we can see that secant is actually positive over here, so it can't be in this quadrant. Secant would be negative in quadrant 2 though. So based on that, we can go ahead and rule out quadrant 4 just because secant would have to be positive over there. Now that we know we're in quadrant 2, let's go ahead and draw a reference triangle so that we can figure out the other ratios. So while we were originally given this cotangent of theta, I prefer to use this tangent of theta instead. So if we're going to go ahead and write this, we know tangent of theta is going to be -1/4. So what's the ratio for tangent of theta? So tangent is going to be opposite over adjacent, also known as y over x, right? So we know the y coordinate and the x coordinate have to be 1 and 4. So up and down, we know it's going to be 1. I'm going to go ahead and write that over here. I'm going to put a positive 1 because we're in quadrant 2. And then we're going to go ahead and draw a line that's horizontal, and that's going to be a -4. So again, 1 has to be positive, 1 has to be negative, but because we're in quadrant 2, they have to be paired up this way where the y is positive and the x is negative. I'm going to go ahead and connect this right over here. That's our r value, or our hypotenuse. Here is our theta. To figure out r here, we can go ahead and use the Pythagorean theorem, where we know that x squared plus y squared is equal to r squared. So this is going to be -4, and we're going to go ahead and square that plus this 1 squared, that's positive, just leave it alone, is equal to r squared. And so that's going to be 16 plus 1 is equal to r squared. That's 17 is equal to r squared. So the radius here is going to be the square root of 17. R is always positive, so we don't have to worry about signs, but keep in mind that this is going to be root 17 for that hypotenuse. Now let's go ahead and take care of sine of theta. So sine of theta is going to be y over r, or this opposite over hypotenuse. So it's going to be 1 over root 17. So we go ahead and write 1 over the square root of 17. But don't forget, we have to go ahead and rationalize the denominator, so multiply that by root 17 over root 17, which is just 1. And if we do that, we're going to get root 17 over 17. Okay, so that's sine, but for cosecant, it's reciprocal. We can flip that upside down, and we'll just get root 17. A little bit less work for that one. Okay, and then for cosine, cosine is going to be adjacent over hypotenuse, or x over r. So that's going to be -4 over root 17. So I'm going to go ahead and write -4 over root 17, which means that secant is just going to be root 17 over -4. So I'm just going to do that right away. And then one of them has to be rationalized. It's this one up here. Multiply by root 17 over root 17. And if we do that, we're going to get -4 root 17 over 17 as our final ratio for cosine. Let's check out a third one here. For number 3, we're given that cosine of theta is equal to the ratio of +24 to 25, and that sine of theta is less than 0. For starters, we know that cosine of theta is equal to this ratio right here, so I'm going to go ahead and just write that in as 24 to 25. So we're given that one, but we also can right away say that secant of theta is going to be 25 to 24. Now let's check out where stuff is positive so we can narrow it down from 4 quadrants down to 1. All right, so cosine of theta is +24 to 25, so it's a positive ratio. So it could be in quadrant 1, but where else is cosine positive? Well, cosine is also positive in quadrant 4. So based on that information, if cosine is a positive ratio, it can't be in quadrant 2. Theta can't be over there. And then theta also can't be in quadrant 3. Now, using the second bit of information, we know that sine of theta is less than 0. Well, where is sine positive? Well, sine's positive over here in quadrant 1, so that means sine must be negative in quadrant 4. So if sine has to be negative, then this angle measure we're talking about can't be in quadrant 1. It's got to be in quadrant 4. So going ahead and drawing this in quadrant 4, we got to remember that cosine is going to be adjacent over hypotenuse, also known as this x over r. Right, so the x coordinate is going to be 24. So I'm going to go ahead and move 24 over to the right. It's going to be a positive 24. And the r value, or the hypotenuse, is going to be 25. So, and for the r value, that's the hypotenuse. So that's a diagonal. That's going to be 25. So that's going to be on a slant here. So that's going to be 25 for r. And what we don't know is this y value, right? This is our y. It's going up and down. We don't know what that is. And then theta is going to be this angle measure right here. Now, to figure out the other ratios, we're going to need that y value, so we can go ahead and use the Pythagorean theorem. So I'm going to go ahead and do that right now. So we now know that y is equal to 7, and just keep in mind that that is going to be a negative 7 because we're moved down below the x-axis. Now if we try to find out what sine of theta is, again, that's going to be y over r, so y over r. And so that's going to be the opposite over hypotenuse, and that's negative 7 over 25. So I'll go ahead and write negative 7 over this 25. And if we know sine, then we know cosecant is going to be negative 25 over 7. And keep in mind that we did know that sine's ratio should be less than 0 because we were given that information, so these should be negative. And then finally for tangent, tangent's going to be what? Opposite over adjacent, or y over x. So y over x. So that's going to be negative 7 over 24. Negative 7 over 24. And that means cotangent is going to be negative 24 over 7. Let's check out number 4. For number 4, we're given that sine of theta is equal to negative 2 root 5 over 5, and that cosine of theta is greater than 0, or positive. All right, so this sine of theta, that's going to be this negative 2 root 5 over 5. So I'm going to go ahead and write that in as our ratio that we're given. So negative 2 root 5 over 5. Okay, and if we're going to go ahead and take that and see if we can flip it upside down. So for this one, let's see, we will flip it and make it negative 5 over 2 root 5. Okay, and if we're going to rationalize this, we're going to go ahead and multiply this by root 5 over root 5. And if we do that, let's see what that's going to be equal to. I think we're going to have negative 5 root 5 over, and then that's 2 times 5, and that's going to be 10. And then we can divide both top and bottom by 5, so it would mean negative root 5 over 2. Now, just to save a little bit of space, I'm just going to get rid of this and move the answer over. So this negative root 5 over 2 is going to be our final ratio. So we have 2 down and 4 more to go. Let's check out where stuff is positive so we can narrow down where to draw our triangle. We know our sine ratio is going to be negative, so where is sine supposed to be positive? Well, sine is supposed to be positive in quadrant 1 and quadrant 2, so it can't be over there, right? So we know theta can't be in quadrant 1, otherwise the ratio would be positive, and it can't be in quadrant 2 for the same reason. So we know we're narrowed down to quadrant 3 or quadrant 4. Now, using the second bit of information that we're told, which cosine of theta is greater than 0, which means cosine's ratio has to be positive. Where's cosine's ratio positive? Well, the only place that's going to be left is going to be in quadrant 4. So cosine would be negative or below 0 in quadrant 3. So we know it's not in quadrant 3. Now let's go ahead and see if we can sketch a triangle. So sine's ratio is going to be opposite over hypotenuse, also known as the y-coordinate over the r-coordinate. So for that y-coordinate, I'm going to go ahead and move negative 2 root 5 down, negative 2 root 5. And for the r value, or the hypotenuse, that's going to be 5, right? And the radius is always positive, so we don't have to worry about signs for that. So this is going to be this 5, which is basically going to be our r value. And theta is essentially right over here. So this triangle makes sense because it's in quadrant 4, and we have a negative 2 root 5 over 5 for the opposite over hypotenuse, or y over r. And what we're going to have to do is we're going to have to solve for the x-coordinate, which is going to be positive because we're to the right of the y-axis. Just like earlier, let's go ahead and use the Pythagorean theorem to figure out what x is. All right, so after using Pythagorean theorem, we found out that x is equal to the square root of 5, and that's going to be positive, so it's going to be positive root 5. And so for cosine of theta, that is going to be the adjacent over the hypotenuse, or the x over r, and so that's going to be this root 5 over 5, root 5 over 5. And then for secant of theta, it's reciprocal, that's going to be 5 over root 5. But keep in mind, we have to rationalize that, so we'll multiply this by root 5 over root 5, and if we do that, we're going to get 5 root 5 over 5. But keep in mind, if we cancel out those 5s, this is just going to simplify down into just being root 5. So let me just go ahead and clear this out and just write down root 5 for the most simplified ratio. And then finally, for our tangent ratio, tangent of theta is going to be the opposite over the adjacent, also known as y over x. So we can go ahead and write that this is going to be negative 2 root 5 over root 5. And so you can notice that those root 5s are going to cancel out, and that's just going to equal -2 for the ratio. And if we flip that upside down for cotangent, that's just going to be -1/2. Let's keep it on going. If you're getting the hang of this, that's great. If you want to try pausing the video and trying some on your own. Otherwise, let's keep on doing this together. For number 5, we're given that tangent of theta is equal to -5 and that cosine of theta is greater than 0. So tangent of theta is equal to -5. Let's take that bit of information first and go ahead and write that in. So tangent is going to be -5. And so that means cotangent is going to be the reciprocal of -1/5. And now let's go ahead and see where stuff is positive. Now, tangent of theta is equal to -5, so that's a negative ratio. Tangent would be positive over here in quadrant 1 and in quadrant 3, but since it's negative for the ratio, we know it can't be there, right? So theta can't be in quadrant 1, and theta also can't be in quadrant 3. It must be in 2 or 4. Now, to narrow it down even more, let's check out this information over here. We know that cosine of theta is greater than 0, which means cosine's positive, right? Now, cosine's positive over in quadrant 4, but it's negative in quadrant 2. So let's go ahead and narrow it down, and we know that we have to be working in quadrant 4 here. All right, so we do know that tangent's ratio is going to be opposite over adjacent, also known as this y over x. Okay, so we now know we can go ahead and take this and say, okay, tangent is supposed to be -5. If we need two numbers, you can just change this and say this is going to be 5 to 1, just so we can see what the y and the x are. Because we're in quadrant 4, the y has to be negative and the x has to be positive. Let me just go ahead and show you that as well. But if we go ahead and draw this in quadrant 4, the y is going to have to be this like longer length because it's going down 5. Right, to be in quadrant 4, it has to have a negative y value. And then for the x coordinate, it has to be positive. So x is moving to the right, so that's going to be +1. And then let's go ahead and draw the hypotenuse in so we can see the triangle. And our theta, our angle measure, is what we're talking about, is right here. Okay, so that's how we knew that y was negative and x was positive, just so that's going to put us in quadrant 4. We do have to go ahead and figure out this r, or the hypotenuse, so I'm going to go ahead and use the Pythagorean theorem to go ahead and do so. So using the Pythagorean theorem, we find out that r does equal the square root of 26. So go ahead and write that information here so that we can write our other ratios. We don't really need this anymore, so I'm going to clear this out for some space. And so for the sine of theta, that is going to be this opposite over hypotenuse. So that's going to be this -5 over root 26, or y over r. So I'll go ahead and write -5 over root 26. And if we're going to go ahead and write that, then we know cosecant is going to be -root 26 over 5. One of these we have to rationalize, so I'm going to do that up here. I'm going to multiply by root 26 over root 26. And if we do that, we'll get -5 root 26 over 26. So that would be the final ratio for sine. For cosine, that's going to be adjacent over hypotenuse, or x over r. So that's going to be the adjacent over the hypotenuse, or x over r. So that's going to be 1 over root 26. Go ahead and write 1 over the square root of 26. And the reciprocal for secant is going to be root 26 over 1, or just root 26. And then for cosine, let's go ahead and rationalize that by multiplying by root 26 over root 26. And if we do that, we will get root 26 over 26. And just like that, we have all 6 trig ratios. Let's try number 6. In number 6, we're given that secant of theta is equal to 2 and that sine of theta is less than 0. So we know here that secant of theta is equal to 2. So I'm going to go ahead and write that in over here. And its reciprocal is cosine, so that's going to be 1/2. And then to move forward here, let's go ahead and see if we can narrow down and figure out what quadrant we're dealing with. So if secant of theta is equal to 2, which is positive, and cosine is positive as well, that means this could be in quadrant 1 and it could be in quadrant 4, because those are the two locations where cosine is positive. And based on that, we can narrow down and say we know that theta is not in quadrant 2 and not in quadrant 3. Okay. Now, to narrow it down one more time, we know that sine of theta is less than 0, so sine must be negative. Well, sine is positive in quadrant 1, so it cannot be there. It's got to be in quadrant 4. So once again, for this one, we are going to be in quadrant 4 for our angle. All right, so cosine is going to be positive over here. And so we have cosine, what's that ratio? Cosine is going to be adjacent over hypotenuse, also known as the x coordinate over the r coordinate. So again, this is going to be our x over r. So we need to move positive 1 to the right. So I'm going to go ahead and put a positive 1 over here. And then our r value, or the hypotenuse of the triangle, we have to go ahead and move 2 units in this diagonal. So that's going to be 2. And we don't know this y value, this up and down value. That's going to be the opposite of our theta. And we can go ahead and use our Pythagorean theorem now to solve for that missing side length. Alrighty, so we found out that y is equal to the square root of 3. Just keep in mind that we make this a negative root 3 just because we are down below the x-axis, so y has to be negative. Once again, I'll clear this out for some extra space. And for sine of theta, we know that's going to be opposite over hypotenuse, or y over r. So here is our y value, and this is our r value. So we're going to have negative root 3 over 2. Negative root 3 over 2. And then that means for cosecant, that's going to be negative 2 over root 3. This one has to be rationalized. We can multiply by root 3 over root 3. And if we do that, we're going to get negative 2 root 3 over 3. And then finally for tangent, tangent is going to be opposite over adjacent, or y over x. So here is our y value and here is our x value. So it's going to be negative root 3 over 1, which is just going to be negative root 3. And the reciprocal is going to be negative 1 over root 3. And so we can go ahead and rationalize that by multiplying by root 3 over root 3, just like we did earlier. And that's going to be negative root 3 over 3. So there we go. Let's go ahead and try just a couple more. For number 7, we're given that cosecant of theta is equal to 3 root 7 over 7, and that cosine of theta is less than 0. So let's go ahead and just take this given information and fill it in to what we have here. So we'll go ahead and say this is going to be 3 root 7 over 7. And then for sine, that is going to be its reciprocal. So that's going to be 7 over this 3 root 7. And if we go ahead and rationalize that, that's going to be multiplied by root 7 over root 7. And if we do that, we should get 7 root 7 over 3 times 7, which is 21. And if we divide top and bottom both by 7, we should get root 7 over 3. All right, now to see where stuff is positive so that we can narrow some things down and fill in the rest of this table or chart. So because cosecant and sine are both positive, that can happen in quadrant 1, and it can also happen in quadrant 2, but they would be negative in quadrant 3 and 4, so we know theta is not in quadrant 3 and not in quadrant 4. Now using this other information, it says cosine of theta is less than 0. That means cosine has to be negative. And so where's cosine negative? Well, cosine is positive over in quadrant 1, but cosine would be negative over in quadrant 2, so we want to be in quadrant 2. It's not here. All right, so we know we are in quadrant 2, and we know we have this, this ratio for sine, which is going to be opposite over hypotenuse, also known as the y-coordinate over the r-coordinate. So our y-coordinate is going to be root 7, and our r-coordinate is going to be 3. So I'm going to have to move root 7 up, positive root 7, and we know that the hypotenuse is going to be this 3. We don't know the x-coordinate. We do know it's going to be negative though, and theta is located here. Now that we have our triangle, we can go ahead and get rid of this to get some more space. And let's use the two sides that we have of the triangle and use the Pythagorean theorem to find a third. All right, so we found out that x is equal to root 2, so make sure we use a negative root 2 because we are in quadrant 2. So writing the ratio for cosine of theta, that's going to be adjacent over hypotenuse, or x over r. So here's our x-coordinate and here's our r-coordinate. So that's going to be negative root 2 over 3. Negative root 2 over 3. And for our secant ratio, that's going to be negative 3 over root 2. And we need to go ahead and rationalize that, multiply by root 2 over root 2. And if we do that, we're going to get negative 3 root 2 over 2. And then finally for tangent of theta, that's going to be opposite over adjacent, or y over x. So here is our y and here is our x. So we have root 7 over negative root 2. So we have negative root 7 over root 2. And that means for cotangent, we're going to have negative root 2 over root 7. Both of these have to be rationalized, so multiply this one by root 2 over root 2. And if you do that, we're going to get negative root 14 over 2, and that can't be simplified. And then for this one down here, we'll multiply by root 7 over root 7. And we will get negative root 14 over 7. Alrighty, one last one, number 8. We're given that cotangent of theta is equal to negative root 7, and that sine of theta is greater than 0. Let's try to go ahead and fill in everything all at once here. So cotangent of theta is going to be negative root 7. So I'm going to write that in as negative root 7. But then that means for tangent, that's going to be negative 1 over root 7. And if we rationalize that, we can multiply by root 7 over root 7. And we should get negative root 7 over 7. So if cotangent is going to be negative here, then it cannot be in quadrant 1 because tangent and cotangent would be positive, and it can't be in quadrant 3 because it would be positive over there as well. And then for sine of theta, that's got to be greater than 0. So where is sine positive? Sine's positive over here, so sine would be negative down here. So theta has to be in quadrant 2. Now our tangent ratio is going to be opposite over adjacent, also known as y over x. So we know we have this negative root 7 over 7, so we are going to be going up root 7. Go ahead and write this as positive root 7. And then our x-coordinate is going to be negative 7. Okay, so just keep in mind that that's going to be opposite over adjacent, or y over x. And if I go ahead and connect this, then we can see our theta is located right here. And so our y over x would get us our negative root 7 over 7 ratio. I'll go ahead and clear this out for some space. And let's go ahead and use the Pythagorean theorem to solve for r. All right, so I did find out that r is equal to 2 root 14, so I'm going to go ahead and write that over here. That's going to be 2 root 14 for the hypotenuse. And if you're wondering about how I split up that radical of root 56, just keep in mind that you can use a factor tree if you want to, but 56 breaks into 4 times 14, and 4 is a perfect square, so that's how the 2 came out, as to making this 2 root 14. Okay, so feel free to go ahead and use your factor trees to help you, but that's how I got that. And let's go ahead and use this information now to find the other ratios. So for sine of theta, that's going to be y over r. So here's our y and here's our r. So I think that's going to be root 7 over 2 root 14. So I think we're definitely going to need some space here. So I'm going to write this on the side to begin with, over 2 root 14. Okay, and we can go ahead and rationalize this, multiply this by root 14 over root 14. And if we do that, we're going to get root, what is that, 98? Root 98 over 2 times 14, which is going to be 28. And root 98 separates into root 49 times 2. I know there's another way I could have gone about this, but root 49 is going to be 7, so it's going to be 7 root 2 over 28. And then divide both top and bottom by 7, that's going to be root 2 over 4. All right, so after all that, we're going to get root 2 over 4 for the sine ratio, which means that for the cosecant ratio, that's going to be 4 over root 2. That's going to be the reciprocal, but that's going to have to be rationalized as well. So if we do that, that's going to be 4 root 2 over 2, and then you can divide top and bottom by 2 to get 2 root 2. Now for this last ratio, I'm just going to clear out a little bit more space. And so for cosine of theta, that's going to be x over r. So here's x and then here's r. that's going to be negative 7 over 2 root 14. And if you rationalize that, I'm going to multiply by root 14 over root 14. And that'll be negative 7 root 14 over 2 times 14, which is 28. And you divide top and bottom both by 7, that'll be negative root 14 over 4. So for cosine of theta, we'll get negative root 14 over 4. And then for secant of theta, that'll be negative 4 over root 14. And to rationalize that, we'll multiply by root 14 over root 14. And we'll get negative 4 root 14 over 14. And then we can divide top and bottom by 2 to get negative 2 root 14 over 7. And there you have 8 different examples of finding all 6 trig ratios given one of them, as well as another bit of information. So just keep in mind you have to narrow down the quadrants that you are in so that you can identify where to draw your triangle, and that will help you with identifying what the ratios are. And if you're interested in downloading this file, the link is in the description and in the comment section. So if you'd like to go ahead and do so and do it with me, or just have the worksheet, then go ahead and do so. Hopefully you found this video helpful. And as always, keep up the great work. I'll see you in the next one.